Hello. Hello, good morning students. I am starting the class. Okay, now yesterday we have done some examples. It is very slow. So I think this is the last example we have done yesterday. So let us do the next example, sixth one. Okay. Page 318. First Roman, first sum, sixth bit. F of x is equal to x cube minus 3x for all x belonging to R. The question is, find the points of local extrema, if any, and a local extrema of the following functions, each of whose domain is shown against the function. Okay, here the domain is R. Okay, yes, so what is the derivative f dash x? 3x square minus 3. Okay, 3x square minus 3. So I can write it as 3 into x square minus 1. That is 3 into x plus 1 into x minus 1. So if you equate it to 0, you will get two values for x. So x is equal minus 1 and x equal to 1. So at these values the function is stationary, because the derivative is 0 means we say that the function is stationary there. Okay, and so to find whether these two stationary points are local extrema or not, we can use the first derivative test. Let us use the first derivative test only. So I'll okay, stationary. So I'm using the first derivative test. So here I am drawing a line. The first derivative is 0 at 2 points. X is equal to minus 1 and plus 1. These 2 points I have to mark on the number line here. What is the name of this diagram? Sine of f dash x, not fx. Sine of f dash x. So f dash x is 3 into x plus 1 into x minus 1. Suppose x is here. then x minus 1 is positive, x plus 1 is also positive, positive into positive, positive. So you will get a positive sign here. Okay. So alternately you will get next negative sign, next positive sign. Okay. Wait just 1 minute. So let us remove this and also this. So at x equal to minus 1, I'll use another color. Okay. At x equal to minus 1, before minus 1, the derivative is positive, means it is increasing or decreasing? Increasing. So after minus 1, the derivative is negative, means it is decreasing. Up to here. Next one, the derivative is positive, so again it is increasing. So therefore clearly at x equal to minus 1, what is there? Local maxima or local minima? Local maximum. So x equal to minus 1 is a point of local maximum, and the local maximum value is what? F of minus 1. So that we have to put in the original function. Okay. Original function, if you put x cube minus 3x, you will get minus 1 plus 3. Minus 1 plus 3, is it not? If you put minus 1 plus 3, that is 2. So here this point is minus 1 comma 2 on the graph. At x equal to 1, you have to calculate f of 1. F of 1 is 1 cube minus 3, that means 1 minus 3 minus 2. Minus 2. So this point is 1 comma 2. So the final answer is like this. X is equal to minus 1 is a point of local maximum, and the local maximum value is f of minus 1, that is 2. Similarly, x is equal to 1 is a point of local minimum. X is equal to 1 is a point of local minimum, and the local minimum value is f of 1, that is 2. So that is the answer for this question. Okay, the graph also will be like this. F of 1 is minus 2, sorry, this is not 2, minus 2, very sorry, this is minus 2. So can I try to draw the graph now? This is an extra thing I am doing. It is not asked to the graph or to draw the graph or anything, but I am doing some extra thing here. At minus 1, this is minus 1, this is plus 1. At minus 1, the value is 2, so this point is minus 1 comma 2, that is local maximum. At 1 it is 1 comma minus 2 below here, and the actual function is x cube minus x, is it not? Sorry, this function is 0 at what points? Sorry, x cube f of x is x cube minus 3x. If you equate it to 0, you will get either x equal to 0 or x square is equal to 3, means x is equal to plus or minus root 3. At these values the function is 0. So at 1 comma, I am drawing the graph here, see, at minus 1 comma 2 there is a local maximum. The function is the graph is passing through the origin like this, and at 1 the minimum value minus 2, and again it is coming up, cutting the x-axis and going up, and here it is going down. So what is this point? Root 3 comma 0. The function is 0 at 3 points, x equal to 0 and x equal to plus or minus root 3, So x equal to 0 means it is passing through origin. X equal to 0, the function is also 0, root 3 comma 0, and this point is minus root 3 comma 0. So the curve is cutting the x-axis at 3 points, minus root 3 comma 0, 0 comma 0, root 3 comma 0. And minus 1 comma 2 is a point of local maximum, 1 comma minus 2 is a point of local minimum. This side it will go to plus infinity like this, and this side it will go to minus infinity like this in the domain R. So this is all some extra thing we have. Now let us go to the next problem. Okay. Seventh one. Let me use some red color. Okay. F of x is equal to x minus 1 into x plus 2 whole square. F of x is equal to x minus 1 into x plus 2 whole square for all x belonging to R. Okay. So let us see the derivative. Sai Vardhan, are you there in the class? Sai Vardhan, please respond.
Yes, sir. Yes, sir.
What is the derivative? Tell me. UV formula. X minus 1 into what?
X plus, sir, 2 into x plus 2.
Very good. Wait. Here, x plus 2 here. Next. Wait. Plus derivative of x minus 1.
Derivative of x minus 1 is 1, sir.
1 into x plus 2 whole square. See, the board is giving trouble. One into x plus 2 whole square.
Yes, sir.
Okay, is it right? X minus 1 into 2 into x plus 2. X plus 2 whole square into derivative of x minus 1 is 1. So I'll take x plus 2 common. Okay.
Yes, sir.
In the bracket I have to write 2 into x minus 1, that is 2x minus 2 plus x plus 2.
3 is into 2 x plus 1, x plus 2.
2 gets cancelled, you will get 3x into
X plus 2, sir.
very good. Okay. 3x into x plus 2. So let us use the let us equate it to 0. You will get two values, that is x equal to minus 2 and x equal to 0. Two values. So these are the stationary points.
Yes, sir.
F of x is stationary at x equal to minus 2 and x equal to 0. Okay. Now this is sorry. Okay, let us mark these two values at x equal to minus 2 and x equal to 0. Let us mark these 2 points. Here the derivative is 0. This is the diagram of sine of f dash x. Okay, so when x is here, x is positive and x plus 2 also positive, so it is positive there. Okay, so then alternately you will get a negative here, next positive here. Okay, so let us remove this. We are using the first derivative test only. Okay, let us see. Right, so here minus 2 and this is 0. Before minus 2 f dash x is positive, after minus 2 f dash x is negative, means before the function is increasing, then afterwards decreasing up to 0, and then afterwards it is again increasing.
Increasing.
So therefore x is equal to minus 2 is a point of what? Local maximum or local minimum?
Sir, maximum. Yeah, that maximum and 0 and 2.
X equal to minus 2, it is a point of local maximum. At x equal to 0, x equal to 0 is a point of local minimum.
Yes, sir.
That we have to write clearly. At the end of the question, the answers must be written clearly. X is equal to minus 2 is a point of local maximum, and x equal to 0 is a point of local minimum. Local maximum value means f of minus 2 you have to calculate. F of minus 2 in the original function. If you put minus 2 here, then you will get getting 0. Okay, f of minus 2 is 0. What is f of 0 at 0? Local minimum value?
Sir, -4.
Minus 1 and 4. So minus 4. Okay. So the final answer can be written like this. X is equal to minus 2 is a point of local maximum, and the local maximum value is f of minus 2, that is equal to 0. Next, x is equal to 0 is a point of local minimum, and the local minimum value is f of 0, that is equal to minus 4. So that's all. Okay. So let us see the next question. 8th one. I will give some problems for homework. For example, second question, second Roman, second question, third question, fourth question, etc. Fifth question, sixth question, except sixth. I think remaining all you can do it. Okay. Anyhow, let us see the 8th question. F of x is equal to x by 2 plus 2 by x. For all x belonging to 0 to infinity. X by 2 plus 2 by x for all x belonging to 0 to infinity. Okay. So let us find the derivative. Now come on. Kunal, tell me the derivative. Kunal. F dash x is what? Tell me.
Sir, f dash x, 1 second, sir. Yes, sir. 1 by 2 minus 2 by x square.
1 by 2. For x derivative is 1, so 1 by 2.
Yes, sir.
For 1 by x derivative is minus 1 by x square.
Yes, sir.
So 2 into minus 1 by x square, minus 2 by x square. So let us take LCM 2x square. Here you will get x square and here you will get 4. So this can be written as x plus 2 into x minus 2 by 2x square. Right. If you equate it to 0, you are going to get two values. X is equal to minus 2 or x is equal to
Plus 2.
and x is equal to plus 2. But minus 2 we should not consider. Why?
Sir, it is not in a domain.
Correct. So minus 2, let us not consider it because the domain is given to be here. X belongs to 0 to infinity only. So minus 2 we don't bother. We'll consider at 2 only. But let us use the first derivative test only. So minus 2. In the diagram you can mark minus 2, no problem. Plus 2. This is sine of f dash x. Okay, suppose x is here. Then x minus 2 is positive, x plus 2 is also positive. And anyhow denominator 2x square is always positive. So you will get positive sign here. Okay, positive sign here. Then alternately you will get negative sign here and then positive sign here. Denominator you need not worry, always it is positive, only numerator minus 2 and 2. So let us remove the unnecessary things so that we can see the diagram clearly. Okay, these things I am removing. Okay, this one. Okay, now this is the clear. So the domain is 0 to infinity. Where is 0? Somewhere here in between. Is it not? So 0 to infinity. This side. 0 to infinity. Now, therefore, x equal to 2 is the only stationary point in the given domain. X equal to 2 is the only stationary point in the given domain because there the derivative is 0. So here before 2 f dash x is negative, means the curve is coming down, decreasing, function is decreasing. After 2 the derivative is positive, means curve is increasing. Therefore x equal to 2 is a point of Kunal, what? Local maximum or local minimum?
Sir, x is equals to local minimum, sir.
Yes, first decreasing and then increasing. So x equal to 2 is a point of local minimum. And what is the local minimum value means? You have to calculate f of 2. F of 2 in the original function. 2 by 2 plus again 2 by 2. That is 1 plus 1, 2. So the final answer is, in the given domain, x is equal to 2 is the only point of local extremum and it is a point of local minimum. And the local minimum value is f of 2, that is 2. That's all. That is the final answer. So let us go to the next one. Next question is ninth one. Ninth one, in my textbook I have put 3 stars for it. That means something important is there in that question. So all of you please follow this. Ninth question is important because I have put 3 stars for this question. Ninth, f of x is minus of x minus 1 whole cube. Minus of x minus 1 whole cube into x plus 1 whole square. X plus 1 whole square for all x belonging to R. Okay, f of x is equal to minus of x minus 1 whole cube whole square for all x belonging to R. Okay, I'll write R here. Right. So let us use the uv formula for finding the derivative. U is minus of x minus 1 whole cube. V is x plus 1 whole square. So u I will write as it is, minus of x minus 1 whole cube, I will write it as it is. Now what is the derivative of x plus 1 whole square? Come on. 2 into x plus 1 over. Next, what is the derivative of minus of x minus 1 whole cube? Minus minus 3 into x minus 1 whole square, that's all. And x plus 1 whole square we will write as it is. In this, what is common maximum, that we have to take common. So I will take a minus common first, both minus is there. X minus 1 whole square is there. X plus 1 is there. See, this question is important. All the students, please follow carefully. This is important. Minus of x minus 1 whole square into x plus 1, that is common. Now what is remaining? Minus I have taken common, so 2 into x minus 1 is there. 2 into x minus 1. Okay. 2 into x minus 1 is there. That's all, is it? And in the first term? Okay. Next, in the second term, minus I have taken common, so plus 3 into x plus 1. 3 into x plus 1. Okay. Okay. This is equal to minus of minus 1 whole square into x plus 1. In the bracket 2x plus 3x 5x. 2x plus 3x 5x minus 2 plus 3 plus 1. 5x plus 1. So I will take, I will make the coefficient of x 1 by taking 5 common outside. I will take 5 common. So minus 5 into x minus 1 whole square minus 5 into x minus 1 whole square into x plus 1 into x plus 1 by 5. This we have to equate it to 0. F dash x we have to equate it to 0. So here we are getting 3 values. X is equal to, least value of them is minus 1. Next, minus 1 by 5. I am writing the values in the increasing order. Minus 1 first, then minus 1 by 5, then 1. This is the order, increasing order. At these 3 points, the function is stationary because the derivative is 0. These stationary points, are they turning points also? Turning point means what? These are stationary points. These for these. No, wait. These are, wait. These are stationary points. Okay, we have to find whether these stationary points are turning points are also or not. So, what is the definition of turning point? Actual definition of turning point is that a turning point of a function is the point where the derivative changes sign. Okay, derivative changes sign either from positive to negative or negative to positive. That point is called turning point. And of course, what you said is also correct. If the derivative changes sign from positive to negative, it is a point of local maximum. If it changes from negative to positive, it is a point of local minimum. Therefore, turning points will be always either, they will be local extrema, either local maximum or local minimum. Okay, that is right. Now, let us use the first derivative test only. I will draw the, to find whether these are local maximum or local minimum. Let us use the, so minus 1 I have to plot here because the domain is R. Entire number line we have to consider. Minus 1, then minus 1 by 5, and then 1. All of you follow carefully. Here there is some point to be mentioned. This is, diagram's name is sine of f dash x. Madhuri, are you there in the class?
Yes, sir.
Shilpita?
Yes,
Shilpita,
Yes, sir.
Tanmay,
Yes, sir.
all of you please be careful here. I am explaining an important point. I think you might have forgotten it. Okay, minus 1 by. So now, suppose x is here, more than 1. What is the sign of the x minus 1 whole square? X minus 1 is positive, plus 1 by 5 is positive, x plus 1 is also positive. So these three are positive, but before this minus 5 is there. So it is negative. So I will put the negative sign there first. So next point is very important. See, negative sign. Okay. So I will remove all the unnecessary things so that there will not be any confusion. Right, these things also I will remove. Right. So negative sign we have written. Generally after negative sign what we do? Plus sign. Okay. Alternately plus sign, minus sign, plus sign we will put. But this is wrong here. This is wrong. This method is wrong here. Why? Because there is a repeated factor here. See, for x minus 1 the power is 2. Repeated factor x minus 1 into x minus 1 2 times. X minus 1 whole square or x minus 1 whole cube. Similarly, x plus 1 whole power 5 something here. X plus 1 by 5 whole power 4 something like that. Powers will may be there. Then we say that they are repeated factors. But repeated factors you should not do alternately. What you should do is, I think I have explained it, but again I have to remind you of this important point. See, here we have put minus n, that is okay. Now we are crossing which value? 1. 1 we are crossing and going to the next interval, is it not? But for 1 the power is what here? You have to see 2. If it is even number, power is even number, there will not be any change of sign of the function. So same minus sign will continue. That is important. Then next we are crossing minus 1 by 5. Minus 1 by 5 here. Here the power is 1, which is an odd number, so sign changes. Next we are crossing minus 1. Minus 1 corresponds to this factor, and here also the power is 1. 1 means odd number, so the sign changes. So this point at 1, why the sign is not changing? Do you understand? Because x minus 1 has got even power. That is why it is not changing sign. So this is the correct method. So now you can easily draw the diagram. We will extend this. So right. I will use some green color to draw the graph. It is not responding. The board is not responding. Wait for the program to respond. Note is not responding. Okay, it has responded. I'll use the green color. Okay. Now see, before minus 1 the f dash x is negative. See, you can see in the diagram. Before minus 1 f dash x is negative means the curve is, the function is decreasing. After minus 1 and before minus 1 by 5 the f dash x is positive means it is increasing. And after minus 1 by 5 it is again, derivative is negative, decreasing. Next at 1 the derivative is 0 means the curve will be flattening like this. Derivative 0 means the tangent will be parallel to x axis, so the curve will flatten like this. So instead of like this, derivative 0 means it will flatten like this. So we think that it will rise up again, but it is not rising. After that also the derivative is negative, so it is again decreasing. Again decreasing. Like this I can write. Okay, now you understand? At 1 there is no maximum, no local maximum, no local minimum. Now tell me, at minus 1 what is happening? Is it local minimum or local maximum? Minimum, correct. Local minimum, correct. Because before minus 1 the function is decreasing, after minus 1 the function is increasing. So minus 1 local minimum. At minus 1 by 5 local maximum. At 1 no local maximum, local minimum. The function is actually increasing or decreasing, tell me? Decreasing. Decreasing here actually. Because before 1 the derivative is negative, after 1 also the derivative negative means the function is actually decreasing there. So there is no local extrema there. There are no local extrema there. What is the local minimum value? F of minus 1. F of minus 1. That is clearly 0. If you put minus 1 here, it is 0. And local maximum value, f of what? 1 by minus 1 by 5. So that you can calculate whatever it is. You can easily calculate and give the answer. Local maximum value and local minimum value you can calculate by putting in the original function. So this question is important. I have put the 3 stars because of this point. Here x minus 1 whole square is a repeated factor. There the sign of the function f dash x will not change. So that is the important point here to be noticed. Okay, let us go forward. Next one, last one. So in this last question is 10th one. F of x is equal to x square into e power 3x. X square into e power 3x for all x belonging to R. X square into e power 3x for all x belonging to R. Okay. Now, Saranya, are you there in the class? Saranya?
Yes, sir.
Come on. Can you give the derivative f dash x using uv formula? X square into, for e power 3x, what is the derivative?
Sir, e power 3x.
E power 3x into, for 3x the derivative is 3.
3.
Right, correct. Just one minute. Here I have to put 3. X square into, for e power 3x, for e power x the derivative is e power x only. So e power 3x, but 3x derivative is 3. Okay. Then for x square derivative
2x.
2x into e power 3x.
E power 3x.
Right. So we can take I think x into e power 3x common. Okay. X into e power 3x common. So in the bracket what do you get here? 3x plus 2. Okay. X into e power 3x common, you get 3x plus 2. So x coefficient, let us make it 1 by taking 3 common outside. So I'll take 3 common, 3x into e power 3x into x plus 2 by 3. X plus 2 by 3. So I have taken 3 common, so x plus 2 by 3. So let us equate it to 0. See, the exponential function e power 3x is always positive. It is never negative, never 0. Any exponential function, 2 power x or 3 power x or 5. So it is always. So if you equate it to 0, you will get only two values. What are the two values? X is equal to minus 2 by 3 and another one is 0. Okay, minus 2 by 3 and 0. So again, just 1 minute. Minus 2 by 3 and 0. So here also let us use the first derivative test only. These are stationary points. Stationary points. Okay. So we have to mark two values, minus 2 by 3. Domain is given to be R in the question. So minus 2 by 3 and 0. The name of the diagram is sine of f dash x. You can forget about e power 3x. It is always positive. So 3 also always positive. Leave them. Okay. So only x and x plus 2 by 3 you have to consider. Suppose x is here. X is positive. X plus 2 by 3 is also positive. So positive into positive, positive. Okay. Then here there are now repeated factors. X alone, not x square or x cube. X plus 2 by 3 also no repeated factor. So alternately you can put the signs. After plus, minus sign, then plus sign. Now let us remove this and this. Okay. Let us extend these lines. At minus 2 by 3, what is happening? Before minus 2 by 3, derivative is positive, means the function is increasing. After to minus 2 by 3, the derivative is negative, means it is function is decreasing. Like this. And again after 0, up to 0 it is decreasing. After 0 again the derivative is positive, means the function is again rising, increasing. So Sharanya at minus 2 by 3, what is it local maximum or local minimum, Sharanya?
Yes, sir, local maximum.
Correct, local maximum. At 0? At 0 from the graph, can you tell?
Local minimum, sir.
Local minimum. So you can write the answer like this. At x is equal to minus 2 by 3 is a point of local maximum. X is equal to 0 is a point of local minimum. Local maximum value is what? F of minus 2 by 3. That we have to put in the original function. Minus 2 by 3 whole square, original function x square into e power. Minus 2 by 3 whole square is 4 by 9. E power 3 into minus 2 by 3. E power minus 2. So this I can write it as 4 by 9 e square. E power minus 2. I can bring it to denominator and write. So 4 by 9 e square is the local minimum value. And the local maximum value is f of 0. Local minimum value f of 0, if you put in the original function, you will get 0 only. So 0 is the local minimum value. Okay. Local minimum value is 0 and local maximum value is 4 by 9 e square. Okay, we have completed all the bits in the first question. Now let us go to the second question. First Roman, second question. Prove that the following functions. So the some problems in the forward I'll give you for homework, okay? Or I'll write the homework questions now. Please make a note of them and try them. Homework. Second Roman also I will do completely. Second Roman, first question I will do completely. Second question you have to attempt. Use the first derivative test to find the local extrema of f of x is equal to x cube minus 12x on R. That we have to do. Then use the first derivative test to find the local extrema. Number 3 also, all of you please try. Next 4, use the second derivative test to find the local extrema of the function. So fourth one also you please try. Fifth one, use the second derivative test to find the local extrema. These are all for homework. Next, sixth one, find the local maximum or local minimum of f of x is equal to minus sine 2x minus x. So these questions you and ninth one, profit function, find the maximum profit. Ninth one, 10th one, all profit problems you complete. 9th one, 10th one. Third question, first one, profit function. Okay, up to there please complete them. So 1, 2, 3, 4, 5, 6, 7, 8 questions I have given for homework. Please complete them. Now the question is, prove that the following functions do not have absolute maximum and absolute minimum. Absolute maximum and absolute minimum. Absolute minimum. So number 1, e power x in R. The function is e power x and domain is R. What is f dash x? E power x only. And you know that e power x is always positive. It is never 0 also. It is always positive. It is never 0 also. That means f of x is strictly increasing. F of x is, derivative is always 0 means strictly increasing. In its entire domain R, on R. So therefore, there will be no minimum value, no more. So limit extends to minus infinity. See, on R, what is the left end? Minus infinity. What is the right end? Plus infinity. Let us go to the left end, leftmost and rightmost end by taking the limits. Limit extends to minus infinity e power x. So, e power minus infinity. E power minus infinity is what? 1 by e power infinity, 1 by very large number, it is 0. So, as you go to the left side on the number line up to minus infinity, the function will be, it will never become 0, but it will be approaching 0. Okay. So, similarly, limit extends to plus infinity. E power x is e power infinity. E power infinity is infinity. So, as you go forward, the function will be going on increasing. So, it will never, there is no maximum value. Actually, the graph is like this. Like this. Y-axis, x-axis, y is equal to e power x. This point where it crosses the y-axis is 0, 1. When x is 0, y is 1. So, as you go to the left side up to minus infinity, the graph will be coming nearer and nearer to the x-axis. So, the value will be approaching 0, but it will never become 0. It will be reducing until and approaching 0. It will be approaching 0 x-axis. The graph will be coming down and down like that. So, it will be approaching 0, but it will never attain the value 0. Therefore, there is no minimum value. Similarly, on the right side also, it will the graph is rising and it will rise up to infinity. So, there is no maximum value also. So, in the entire domain R, there is no maximum value, there is no minimum value. Okay, absolute maximum, not local maximum. Local maximum, of course, there are no local maximum, local minimum are there, because this is a differentiable function and the derivative is never 0. For a differentiable and continuous function, if there are any local maxima or local minima, there the derivative will be definitely 0. But derivative is not 0 means there are no local maxima, local minima. And absolute maxima, minima are also not there. And the maximum value is infinity, the minimum value is 0. It is approaching 0, it will never attain 0. Okay. So, okay friends, I think it is 10 o'clock. So, we'll close the class now, because the next class is Sanskrit class is there. Okay students, we'll meet tomorrow again. Okay.
Thank you, sir. Bye, sir.
Bye. Okay, okay.
Good morning and thank you, sir.
Okay, right. Please try to do the homework.